Our lesson today is to be able to find the slope of a line using a graph, 2 points, or a table. All right. Slope is the rate of change between any 2 points on a line. It is the measure of the steepness of a line. To find the slope of a line, we find the ratio of the change in y, or vertical change, to the change in x, your horizontal change. We can find slope by using the ratio of the rise to run. The rise is your vertical change, your run is your horizontal change. We can call that the change in y over the change in x. Or I can use what's called the slope formula, where I'm given two ordered pairs and I use the slope formula to find the slope. Positive slopes rise from left to right. Negative slopes fall from left to right. All right, so here are a couple of examples. If I want to describe the slope of the line, I'm looking for a numerical value for the steepness. First, I see that the line rises from left to right, so I know that the slope is positive. The vertical change is 5, the horizontal change is 6, so the slope of the line would be 5 over 6. And it is positive because the line rises from left to right, so I would write that as m, which is equal to 5 over 6. My next line, I notice that it falls from left to right, so I know my slope is going to be negative. The vertical change is 3, the horizontal change is 2, so my slope would be negative 3 over 2. All right, let's look at these three examples. All right, we draw a vertical line and then a horizontal line, creating a right triangle connecting the 2 points. So I'm going to start with my vertical line, then my horizontal line connecting the 2 points that are given. The vertical change is a change of 1. The horizontal change is a change of 5 because it's 1, 2, 3, 4, 5 units long. But the line falls from left to right. So I know my slope has to be negative because the line falls from left to right and it falls at a rate of 1 over 5. My vertical change is 1. My horizontal change is 5. So my slope for that first line is going to be negative 1 over 5. My second line, right, my line rises from left to right. So my slope's going to be positive. I draw a vertical line and a horizontal line connecting the 2 points. My vertical change is a change of 2 because that segment is 2 units long. My horizontal change is 1, 2, 3, 4, 5, 6 units long. So my slope has a vertical change of 2, a horizontal change of 6, but we like to write that in simplest form. 2 over 6 simplifies to 1 over 3. The line is positive, or the slope is positive, because the line rises from left to right. If we look at our third example, I see that the line rises from left to right, so the slope's going to be positive. I draw a vertical line and a horizontal line connecting 2 points on the line. My vertical change is 1, 2, 3, 4, 5. My horizontal change is 2. So my slope, m, is going to be equal to 5 over 2, and that's going to be positive. So if we're given a line on a graph and we want to find the slope of that line, I use the change in y over the change in x, or what we also call the rise over the run. All right, your rise being your vertical change, your run being the horizontal change. Okay. What about the slope of a horizontal line? Well, the slope of a horizontal line is going to be a slope of 0 because it has no steepness. We're trying to assign a numerical value for the steepness of a line. Slope is to describe the steepness. Well, a horizontal line has no steepness, so the slope here is going to be 0. But let's look at this mathematically using our slope formula. So our slope formula says that m, which is our slope, is equal to y2 minus y1 over x2 minus x1. And I like to assign my first ordered pair as my x1 and y1, meaning my first x value and my first y value, and then my second ordered pair, that's going to be my x2 and my y2. Now, why do I assign them values of x1 and y1, x2 and y2? Simply so that I know that I substitute correctly into my formula. So my y2 value is 5, my y1 value is 5. So in the numerator we have 5 minus 5. In the denominator, my x2 value is 6, My x1 value is -1. 5 minus 5 is 0 in the numerator for our vertical change. My horizontal change is 7, right? Because 6 take away -1 is 7, right? But mathematically, there is our slope of 0. Well, what about the slope of a vertical line? Obviously, it has some steepness, right? Because it just goes straight up. But we want to assign a mathematical value to the steepness of that line. All right, so let's do that, right? Using the same slope formula. x1 and y1 for my first ordered pair. And then my second ordered pair, let's make that x2, y2. Okay? We write our formula. M is going to be equal to y2 minus y1 over x2 minus x1. We substitute into our formula. y2 is 2, y1 is 6. So in the numerator, we have 2 take away 6. In the denominator, 4 take away 4. All right? When we do this mathematically, we wind up with 2 take away 6 is -4, but then in the denominator, we have 0. Well, we all know that we cannot divide by 0. So the slope of a line that is a vertical line, we call that an undefined slope, right? Undefined. And it's undefined because mathematically we cannot divide by 0, and a vertical line will give us a slope with a denominator of 0. Okay, well, let's take a look at these examples, right? We're going to use our slope formula for 4, 5, 6, and 7. So let's start with problem 4. All right, problem 4, we write our formula. M equals y2 minus y1 over x2 minus x1. We substitute our values, right? And I always like to do this: x1, y1, x2, y2, just so I know what I'm substituting. y2 minus y1 is going to be -2 minus -2 in the numerator, and in the denominator, x2 minus x1 is going to be 7 minus 1. In the numerator, when we add the opposite, right, we add the opposite, -2 plus 2, we're going to get 0 in the numerator. We get 6 in the denominator. So for problem 1, that's a slope of 0. Problem 1 gives us a slope of, or problem 4 gives us a slope of 0. Let's look at problem 5. Right, start with my slope formula. M equals y2 minus y1 over x2 minus x1. All right, let's assign values here: x1, y1, x2, y2. In the numerator, we have 4 minus 4. In the denominator, we have 3 minus -2. That's going to give us 0 over 5 for our slope, all right, which means problems 4 and 5, you'd have horizontal lines because each of those lines has a slope of 0. All right, let's try problem 6. Here's x1, y1. Here's x2, y2. We substitute. Problem 6, write our formula. M equals y2 minus y1 over x2 minus x1. We substitute our values. That's going to be -5 in the numerator minus, what's that, -3. And in the denominator, we're going to have -3 minus -3. Well, in the numerator, when we add the opposites, -5 plus 3, that's going to be -2 in the numerator. In the denominator, when we add the opposite, that's going to be 0. So this would be an undefined slope. All right, that's going to give us a slope that is undefined because we cannot divide by 0. All right, let's look at number 7. Problem 7, let's identify x1, y1, x2, y2. write our formula. M equals y2 minus y1 over x2 minus x1. We replace y2 and y1, so that's going to be 0 minus 8 in the numerator, and in the denominator we're going to have 0 minus 0, right, which is going to give us negative 8 over 0, and we know we cannot divide by 0, so once again that will be a slope that is undefined, right? That's going to be an undefined slope. Alright, undefined. Okay, let's continue. Okay, when we're finding a slope from a table, right, there are a lot of different ways to do it. Your textbook actually tells you to take, right, two ordered pairs, right? This is an x value, this would be a y value, so this would be 1 comma 8, right? So I could write that as 1 comma 8, and then take this as an ordered pair, 4 comma 6, 4 is your x value, 6 is your y value, and you could use the slope formula, right? We could do m is equal to y2 minus y1, so that's going to be 6 minus 8 over x2 minus x1, that's going to be 4 minus 1, and we wind up with negative 2 over 3, right? So we could take any two ordered pairs. But instead of doing that, right, we can also do the following. We can use the ratio of the change in y to the change in x. So we could also do this, right? I look at my ratio here. I go from 8 to 6, that's a decrease of 2. From 6 to 4, that's a decrease of 2. Right? From 4 to 2, that's a decrease of 2. So my change in y is negative 2. So if I use my slope formula as the change in y over the change in x, my change in y is negative 2. Well, what's my change in x? From 1 to 4, that's an increase of 3. 4 to 7, that's an increase of 3. 7 to 10 is an increase of 3. So I see that constant change in the denominator is positive 3, and I still get a slope of 2 over 3. So when we have a table, I like to use the ratio of the change in y to the change in x, right? Because I think we're less likely to make a mistake that way. Sometimes, and especially after checking some of your papers today, I saw that we make some mistakes with the slope formula and our integers, and I think you're less likely to make a mistake if we use the ratio of the change in y to change in x. All right? So let's go to our next page. Right, we have two tables, right? So I'm going to use the ratio of the change in y to change in x to find the slope. So my change in y, here I have an increase of 3. Here's an increase of 3. Here's an increase of 3. Here's an increase of 2. Here's an increase of 2. Here's an increase of 2. So my slope, my m, is the ratio of the change in y to the change in x, and that's going to be equal to 3 over 2. Make sure that you write it as a ratio of change in y to change in x, because that students will often make mistakes putting x over y, but it's always going to be the ratio of y to x. Alright, let's do problem 10. From 6 to 4, that's a decrease of 2. 4 to 2, decrease of 2. 2 to 0, decrease of 2. From 3 to negative 2, that is an increase of 1. From 2 to negative 1, increase of 1. From negative 1 to 0, that's an increase of 1. So if I write my slope as the ratio of the change in y to the change in x, that's going to be equal to negative 2 over 1, or a slope of negative 2. Alright? Just to kind of summarize what we've done here, positive slopes rise from left to right, negative slopes fall from left to right, horizontal lines have a slope of 0, undefined lines have, or vertical lines have a slopes that are undefined. Okay, now a little practice for you guys. Sometimes, if you remember the examples from earlier in the lesson, when we did the earlier examples, we saw that points were given to us on the line, and we were able to use those points to find the slope. But very often, you're going to be asked to find the slope of lines that are drawn on a graph where you're not given clear intersection points. So it's up to us to find clear intersection points on the line. So let's look at this first example. Here I see a clear intersection point on the x-axis. I see on the x-axis it's 0. On the y-axis is 0. Notice this intersection point here. I very clearly see the y-intercept, or the y value is going to be, oops, the y value is going to be -2, but I don't know the exact x value, so I don't want to use that point. But I want to use this point here because I know the exact x value is 2, the exact y value is 4. Our vertical change here from 0 to -4, vertical change of 4. My horizontal change from 0 to 2 is a horizontal change of 2, right? But the line goes down from left to right, so my slope is -4 over 2, which simplifies to -2 over 1. Right here I can choose any 2 points, so I'm going to choose this point here and this point here. I know the exact x value of this point is 5, the exact y value is 4, and I know the exact x value of this point is 3, and the exact y value is going to be 2. So I'm going to use these 2 points. My vertical change is 2, my horizontal change is 2, well that's real nice. My m is going to be equal to 2 over 2, which simplifies to 1 over 1 for problem 8. Alright, we have 2 more to do. Let's look at this line here. This one's a little trickier. I can't use this point, but I can use this point here. I can't use this point because I know the exact x value, but I don't know the exact y value. Can't use this point here. I know the exact x value is 3, but I don't know the exact y value, but I can use this point here. I know the x value is 4, the y value is 3, so I'm going to use these 2 points. Vertical change is 2, horizontal change is 3, line rises from left to right, so m is going to be equal to 2/3. And then the last problem we're going to take a look at, right? I can use, let's see, not this point, not this point. I can use this point here. That's a good one. I could use this one, or I could use this one. They're all good points. Vertical change, horizontal change. Vertical change of 3, horizontal change of 2. But the line falls from left to right. We have to be careful with those negative slopes. So my m is going to be equal to 3 over 2, but because the line falls from left to right, it's going to be negative. Right? So that's going to be -3/2 for my slope. Okay, I hope that is helpful, and we will see you soon.